Today's our topic is the diesel cycle engine. It is also known as the constant pressure cycle. It is also known as the constant pressure cycle. There are the four process. One and two are the isentropic process. Two and three are the constant volume process. Three and four are the isentropic process. Four and the constant volume process. Heat addition at the constant process. Heat rejection at the constant volume process. Work done compression and the work done expansion are the isentropic process. Similarly, it is showing on the TS diagram process 1 and 2, 3 and 4 are the isentropic process, and the process 2, 3 is the constant pressure, and 4, 1 is the constant volume process. Now we are moving to the next slide. The 1 8 is the adiabatic compression, 2 and 3 is the adiabatic heat at a constant pressure, 3 and 4 is the adiabatic expansion, 4 1 is the heat rejection at the constant volume. Now, the question is how do we find the thermal efficiency of the heat engine? That we moving to the next slide. The thermal efficiency. What is the thermal efficiency of the diesel cycle? The thermal efficiency of the diesel cycle is given by heat addition minus heat rejection divided by the heat addition. The heat addition at the constant pressure, that is the AMCP T3 minus T2. The AMCP T3 minus T2 and heat rejection MCV T4 minus T1. That is the heat rejection MCV T4 minus T1 and divided by MCP T3 minus T1. After we divided MCP T3 minus T2, MCP T3 minus T2, that is the 1 and minus MM cancel out. CV by CP T4 minus T1 T3 by T3. We know the value of CP by CV is gamma. That is we known as the 1 by gamma. T4 minus T1. Now we are moving to the process 1 and 2. The process 1 and 2 are the isentropic process. That's why we have a relation Tv gamma minus 1, that is the process 1 and 2, that is a given T2 is equal to T1 V1 by V2 gamma minus 1. And V1 with V2 we also know that is the compression ratio, or that is the T1 R gamma minus 1. Similarly, in the process 2-3, in a process 2-3, here is the P constant. Then we can write V2 by T2 is equal to the V3 by T3, and T3 by T2 is equal to V3 by V2, and this is nothing but the RC. Our RC is known as the cutoff ratio. Here we process 2-3, V3 by V2 is known as the cutoff ratio. Then equation 3.34 and equation 3.35, we can got T3 is equal to T1 R gamma minus 1 into RC. The equation T4 is given. T1 is the R gamma minus 1, and equation T3, T2 is R, putting the value, we got the answer. Considering similarly the process 3 and 4, that is the expansion process or power stroke process. This is the isentropic process. Also, we have a relation T4 is equal to T3 V3 by V4 gamma minus 1. Next, T3 we divided V2 and multiply by V2. We also know that the V3 by V2 is the RC, and V4 is equal to the V1 because this is the constant volume process. That's why we can write RC divided by R, because V3 by V2 is RC and V1 by V2 is R. That equation, from equation 3.6 and 3.7, we can got T4 is equal to T1 R gamma minus 1 RC R gamma minus 1 to the power 2 RC gamma minus 1. Now we moving to the third slide, where the diesel efficiency, we have a equation 3.33 1 minus 1 gamma into T4 minus T1 divided by T3 minus T2. Then putting the all values and solve, we got the diesel efficiency. The diesel, what is a diesel efficiency? The diesel efficiency is 1 minus 1 by R, that is the compression ratio gamma minus 1, into RC, that is the compression ratio gamma minus 1, gamma RC gamma minus 1. In the next slide, we have a discuss work output of a diesel engine. What will be the or work output of a diesel engine? Now we are moving to the diagram. In a diagram, there is a four process. Process 1 and 2 isentropic process. Process 2 and 3 is a constant volume process. 3 and 4 is the isentropic process and the constant volume process. We know in a constant volume process, total work done is a zero. It means the work done of process 2, 3 plus process 3, 4 plus process 4, 1 and process 1, 2 is W net. Now here in a process 2, 3, here the P is the constant and volume is the increases, that PdV work done. In a process 3, 4, that is the isentropic process, that is the isentropic process, the work done is a given, minus, that is the process expansion process, the compression process is a given, process 2 and 1, all we are starting to solving. If we took a common V2, then this is the V3 by V2, then V3 by V2 nothing but the compression ratio, cutoff ratio, RC minus 1 plus we divided by V2 and multiply by V2, V3 by V2, again cutoff ratio, again we divided by V2 and multiply by D2, that is V1 is equal to the V4, that is the R. If we multiply same way and solving, we can got the work done equation like this. Next, we are moving to the mean effective pressure. How do we find the mean effective pressure? The mean effective pressure is given by total work done divided by the swept volume. We have an equation of the work done is this. We are putting that equation here and this expression are for the swept volume. And we find out the total mean effective pressure inside the cylinder in a diesel engine. Next lecture, we have a discuss a dual cycle. Thank you.